Today we will discuss the preparation of the preparation of the alkyl halide from the alkene. The preparation of the alkyl halide from the alkene was discussed in the last year in the hydrocarbon chapter. We discussed the Markovnikov rule and the peroxide effect in the last year, and where this reaction was there. The reaction of the alkene with the hydrogen halide, then it will form the alkyl halide. In that reaction, we discussed that whenever this is the symmetrical alkene, when the hydrogen halide is added to the symmetrical alkene, then hydrogen and the halogen is added to the carbon atom of the double bond. The respective carbon atom, one carbon atom, another carbon atom, the hydrogen will added to here, and the X is added to here, or X is added to here, and this is hydrogen is will be added to here. What is symmetrical alkene? We know that symmetrical alkene are those alkene where that the carbon this is double bond, suppose, and this is CH3, this is CH3, and this is H, this is H. You see that the methyl group is one methyl group is here and one methyl group is here. This is the double bond. So in that side of the double bond, the one hydrogen and the methyl group is here, and that side of the double bond, one hydrogen and methyl group is there. This is symmetrical alkene. Similarly, we can say just ethene. Ethene is a symmetrical alkene. It's a hydrogen is present around the double bond. So this is symmetrical alkene. Whenever this the hydrogen halide HCl is added to here, then this is positive electron and this is negative, partial negative character, and this will goes to the any carbon atom, and it may go to this carbon atom or this carbon atom or this carbon atom or this carbon atom. It will form the CH H H or Cl H H H, or it will goes to or it may be formed this Cl is added, or it may be ClS. There's no any problem whenever the addition takes place. But in case of the unsymmetrical alkene, what is unsymmetrical alkene? You see this alkene, that this and this alkene, this carbon, at this carbon, the two hydrogen atoms are here, then here one carbon atom and one alkyl group is here. This means that this carbon atom, the hydrogen 1, here hydrogen 2, one alkyl group is present. So this is the unsymmetrical alkene. That is, the groups present around the double bond side are different. And so here that the alkyl halide whenever added, then according to the Markovnikov rule, we discussed in last year that a hydrogen will added to that carbon atom where the more number of the hydrogen present. That is, the hydrogen will goes to that carbon atom and X will go to that carbon atom. So this compound, their product will be that RCHXCH3. For example, we can say in this example, this is CH3, CH, CH2, H, Br here. The H will goes to that carbon atom and Br will goes to that carbon atom. This is partial positive character, this is partial negative character, as the bromine is the highly electronegative than the hydrogen. Then this product will be this. This is the addition is follow the Markovnikov rule. The another one is that the peroxide effect. This reaction is same. This product, the unsymmetrical alkene, we know this is also same. Whenever the peroxide, the hydrogen peroxide or the benzoyl peroxide is used here, then the product will be reverse of that. Here you see that the halogen is added. The halogen added to that where the less number of the hydrogen present. But here the halogen is added to the more number of the hydrogen present. You see the more number of hydrogen present where here at the carbon more number of hydrogen, and this is halogen will be added, and the hydrogen will be added to less number less carbon the carbon atom where the less number of hydrogen present. So this, for example, you can say here this is hydrogen, this hydrogen will added to that carbon atom, Br added to that, and this will be product. So you can see the mechanism how the last year we discussed the mechanism, but today we'll again discuss the mechanism how the reaction occurs, the Markovnikov addition. So you see that RCH double bond CH2, suppose. So you can say the CH3. You can say example, just for example, this example we say CH3. This example you can take this example. So CH3 CH2 plus SBr is equal to the reaction is that. So the first one is this, there are two steps and mechanism will occur. The first step is here it will breaks to the S plus and Br minus. Then this CS3 and CH double bond CS2 that will here combine with the S plus ion. So you see that this methyl group has a tendency to release the electrons, and so it will give the electrons pairs towards this, and therefore this the carbon atom and this carbon atom CS3CH the pi bonded electron here, this pi bonded electron is a very loosely bound electron, and this will goes to that position of that carbon atom. So if the electrons will goes to that carbon atom, then it will be positive, and this S plus will add it to that. Again, if the carbon atom, the pi bonded electron goes to that side, then it will be CS3CH positive and CS, it will be negative, and this S plus will goes to that carbon atom, and it will be CS3. In the last year we discussed the carbocation and the carbon ion and the free radical. So from the carbocation, if you remind that the three carbocation is there: primary carbocation, secondary carbocation, and tertiary carbocation. With the tertiary carbocation is very stable carbocation, then then secondary, and then primary. You see here, this is the primary carbocation. Here one alkyl group is present here, and this is CH3CH3. So this is CS2. This is one alkyl group here, and this is primary carbocation. You see here that carbon atom, this is alkyl group, this is alkyl group, this is secondary carbocation. The secondary carbocation is highly stable than that of the primary carbocation, and therefore this bromide ion here, this plus is already used here. This bromide ion, which is not used here, and this will react to combine to this one. Where this bromide ion will go? This side or this? It will goes to that. This was because there is a high stable, and so this bromide will add to here, and then it will become this CH3 CH CH3 CH Br CH3, and this will be the major product. So why it is major product? This carbocation form is secondary carbocation. This is the mechanism how the Markovnikov addition occurs. Thank you.